we want to write something as a mixed radical. And actually, right before example 2, there's a little note above it. I'm going to just highlight it. Since you're allowed to multiply any square roots, and multiplying and dividing are very similar, you can also break things up with dividing, or combine things with dividing. And sometimes this can be really nice and really helpful. So this is right above, right above example 2. So now if we go to example 2, I notice that in A, I want to write as a mixed radical, and I'm dividing, so I might, just to make my life a little bit easier, do preliminary breaking up, put a cube root on the top of my fraction, a cube root on the bottom of my fraction. And if I want a mixed radical, then I'm going to need to break up if possible, I don't even know if it's possible, I need to break up 16 and I need to break up 135. So we go to our powers chart. Because they're cube roots, we would look at our powers of 3. The very first power of 3, that's listed, because obviously 1 times 1 times 1 we didn't list. But the very first power of 3 we listed was 2 times 2 times 2, which is 8. Does 8 nicely divide 16? Yes. It's going to be 8 times 2. Now, with the negative, I'm going to put the negative with the 8, because if you have a negative inside of a cube root, or a fifth root, or any odd root, it's okay. And it actually can be pulled out in front. Because negative 1 times negative 1 times negative 1 is still negative 1. You can never have a negative inside of a square root, a fourth root, or any even powers. Because it's never possible to multiply the same thing together and get a negative answer in our real numbers. Now 135. So I would check 8 first. Does 135 divide nicely by 8? No. The next number on my powers chart after 8 for cubes, is 27. Does 135 divide by 27? It does. So I would put the 27 here and 5 there. Notice that when we're trying to simplify it, we're only using and checking the numbers on our powers chart. Even though 135 might divide by 3, it's not useful because 3 isn't a cube. It isn't in our powers of 3. Now I can take this and I can say, well, the cube root of negative 8, that's actually negative 2. And I'm left with the cube root of 2. And on the bottom, the cube root of 27, that's actually 3. And I'm still left with the cube root of 5. So I broke it up. And now I can put it back together. The numbers in front I can write as a fraction, as negative 2/3. The cube root divided by the cube root I can write as one big cube root of 2/5. And now because I have a number out in front and a radical, I have a mixed radical, and my answer is finished. Part B wants us to write this, negative 3, fourth root.
Sorry for the interruption. Teachers, please come to your mailbox before period 5 to get your period 5 attendance sheets. Students who are going to the dance, please remember to go to period 5 for attendance and show your teacher your ticket. Students who still want to go, they will be on sale in the front foyer at lunch. And students who paid for them online but did not pick them up can pick them up in hairstyling with Ms. Volbister. Thank you so much.
negatives. Tell yourself to be careful with negatives. Here, they ask us to put it as an entire radical. We have a negative, and because it is an even radical index, you can never put a negative inside of an even radical index. So the negative will have to stay out in front. If it was an odd number, you could put the negative inside and truly have an entire radical. Feels like we don't truly have an entire radical here because we have a negative one in front, but it is accepted. So now we go to our powers chart, and powers of 4, because we're doing a fourth root. 3 to the power of 4 would be 81, so there would be an 81 inside of here, and I still have the 2 and the root 27. 81 is technically 81 over 1, so that might help us do our mental math. Okay, 2 ways we could go about this. 1, how do you multiply fractions? Multiply the tops, 162, multiply the bottoms, 27. And then, does this simplify? Yes. It simplifies to 6, right? Because you all know your 27 times table so well that when you saw 162, you were like, oh yeah, 27 times 6. No, I'm pretty sure nobody, maybe some of you were like, yeah, 10. And some of you are like, oh, I got up to my 12 times table. I don't know if many of you have pushed it beyond that to be like, there was a time I pushed myself and really knew my 20 times table for a while. Because I found a stupid app which you could do your 20 times table, and the faster you were, the more points you got. And then I got like highly ranked in the world, so it so I was like 17 times 16, 272. I just like knew them all like super fast. I don't know how useful that is, but I was pretty good at my 20 times table for a bit. Anyways, so probably you don't know your 27 times table. So I do want to show you that there is some mental math here that you can make your life easier. When you're multiplying and dividing, here I multiplied first. But you could also choose to divide and simplify. And since 27 is my powers chart of 3 and 81 is in my powers chart of 3, this is actually quite easy to see that 81 divided by 27 is just 3. And then, even for those of you that only have your times table up to 4, you are set, because you would just have 3 times 2 left. So, questions for practice on this one. 3, 4, 7, and 8.